I'm Carter, and I am a great horned owl adult.
Jacob. Annoying? Maybe. Juvenile great horned owl? Yes.
Shawn. I'm an adult human and amateur ornithologist.
And this is Steve. Note those great horned owl characteristics.
And they'll be living together for the next week on this season of 1.5 Owls. And a guy.
We have one competition on this show, boys. Don't forget, the winner gets Dad's cookies. This is a race. 3, 2, 1, go.
Each of the dog.
That is pathetic. You're out of breath already? That's hilarious. You're horrible. You can't breathe right. So we weren't really making fun of him. We are just that much more efficient at breathing than he is. This is the respiratory system of a bird, actually an owl, which is slightly different than some other birds, and it's summarized into 4 steps. First step being the first inhalation is when air from outside comes through the trachea and into the posterior air sacs. The second step is the first expiration, the first time you breathe out. It moves from the posterior air sacs into the lungs, right there. It's the only place in this whole process that oxygen actually enters the bloodstream. The third step is the second inhalation, where the oxygen moves, or the air moves from the lungs into the cranial air sacs, all these other air sacs up top here. And then the fourth step is the second expiration, where the air moves from the cranial air sacs up here back outside. This is so much more efficient than in people like Shawn, because the oxygen only goes through the lungs in one direction. So in people, the oxygen is getting mixed in with old air and fresh air, and you're only getting a little bit of the actual good air. Where in birds, over 98% of the air that travels through the lung is captured because it moves in a one-way process.
How's your week been so far?
I can't stand this. Jacob is so annoying.
Yeah, so my week's been pretty good. It's kind of roomy in here. It's not too bad. The guys I live with are great. As many Dad's cookies as I want. It's fantastic.
Carter says you're annoying.
He what? He thinks I am annoying. That guy grunts when he's trying to attract a female.
Those of you who don't speak owl, I've translated this clip for you.
One of me?
When he's stressed out. An owl that barks. I can't even believe it.
Translation.
This is doing like an hour. I'm so stressed.
The nest. Don't even get me started on that one. The beak clicking, the squawking, it's enough to make your ears bleed.
Translation.
Get away from my nest!
Last but not least, that quintessential hoot that you hear, that's when you're getting too close to his territory. The Dad's cookies, his nest. Ugh.
Shut up! This is my territory!
Me. I make 2 noises. 1, hunger.
Translation.
Hunger. I am feeling the hunger. Hungry. 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 I I'm feeling it. The hunger. Distress. Ah!
Translation.
Oh! Blackboard marks just went up. With bonus marks?
Hungry, 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 hungry.
Okay, Carter's right. You're annoying. Not only are you gonna make me deaf, but you're gonna burn out your vocal cords too.
Vocal what?
Okay, so it turns out birds don't actually have vocal cords. What they do have is this thing called a syrinx. And it's an organ that's embedded in the respiratory tract. And the way that it works is after the bird breathes in and is breathing back out, the air rushes past the medial and lateral tympanic membranes, which resonate and produce sound, the same way that a human's vocal cords would. And the way that it's split up, they can actually produce two sounds at once, which allow birds to they sing duets with themselves, essentially. And the sounds are modulated by these pairs of modulating muscles, which differ depending on the species. And this pestulus here in the center is not actually involved in sound production. It's simply a bar of cartilage, but it is necessary to support the tympanic membrane, so I've included it. Okay, a couple quick things though that I should mention. One is that the great horned owl in the sounds that I studied doesn't produce harmonics, so it's not producing a single sound in each side of the syrinx. More than likely it produces the same sound on both sides at once. And another thing I should mention is that there are some birds that don't even have a syrinx, such as New World vultures and things of that nature.
So over the past week of living with these owls, I've learned a lot about their vocalizations, and so I've compiled a few graphs of the data that I collected. Now, the first graph is the average call length. So this would be the length of a single hoot from an adult or a single screech from a juvenile. And as you can see by this graph, the length of a single juvenile screech is 0.519 seconds, and the length of a single adult hoot is 0.256 seconds. The next graph is the average highest frequency, and for this we can see that the juvenile's average highest frequency was 11 kilohertz, and for the adult it's only 2.86 kilohertz. So the third graph is the average lowest frequency, and for this we can see that the juvenile's average lowest frequency is 0.37 kilohertz, and the adult's is 0.63 kilohertz. So it's interesting to note that the juvenile possesses both the highest average high frequency and the lowest of the low frequencies, so its vocalization range entirely encapsulates the adults. And the fourth graph is the predominant frequency. And for the juvenile, their predominant vocalization frequency is 11 kilohertz, while for an adult it is only 4 kilohertz. Now this next graph is a plot of the length of sound versus just which sound was analyzed, and so we can see here that for the juvenile it had one sound just under 0.5 seconds and one sound about 0.56 seconds. And for the adult, we can see the true range of what we were saying earlier, where its length of sound was averaging at 0.256 seconds. This next graph is the highest frequency of the sounds analyzed, and again it just shows our average highest frequency data before. This is just a better way of representing less processed data. From these graphs you can tell that I had a harder time recording the juvenile, as we only had two distinct vocalizations recorded, whereas for the adult we had a lot more to work with. Now this last graph is the lowest frequency of sounds analyzed, and it's very similar to the first, or rather the one that I showed earlier, but again you can see what I was saying about the juvenile's range of sounds encapsulating the adults. So before, the highest frequency was much higher than the adult's highest frequency, and now in the lowest frequency data set, the juvenile has a lowest sound. So lastly, I just want to show you a couple of sonogram waveform pairs. If you look, the top there is the Juvenile Screech, and as I've said a couple times now, it doesn't last very long, only about 0.5 seconds. And there don't appear to be any harmonics in the call. And below that, looking at the adult waveform and sonogram, we can see again that a single hoot, as highlighted in red, lasts about 0.25 seconds, while the entire hooting sequence, if you look at the numbers, lasts about 3 full seconds. And again, there aren't any really distinct harmonics in these owl calls, which makes sense because they're non-passerine birds.
All right, amateur ornithologist, so how did your week go? How is it ending?
You know what? Overall, I'd say I had a good time. The juvenile owl really got on my nerves a couple times, but overall, you know, it was really fun, and I learned a lot. And it's a great way to stay in shape.
I just don't see how they're going to be able to tell who the juvenile and who the adult owl is.
Just make the adult wear a tie. Adults wear ties.
It's logic, I guess.